Hello students, welcome back to my channel. So we have been learning the implementation of the various SQL commands what we have studied. Today's session also we are going to learn few commands and we will see how to implement them using the structured query language. The very first command what we will be learning is the join. So joins we have studied in detail thoroughly with all the examples in the previous sessions, especially in the previous chapter, database concept, where we have seen how does the join work, right? So in these joins, we use in order to retrieve the tuples required from the database. Hence, we are going to use them as well in the SQL. So let us see how it works. So before we get on to the practicality of it, let us see what is a join once again. Joins class is used to combine records from two or more tables in a database. Just like I told you, and just like the name says, join usually means that joining something. So here what we do is we combine two tables and there is a certain conditions on the basis of that, we will retrieve the required tuple. Okay. So a join means for combining fields from two tables by using the values common to each. So what we are going to use is the comparative operators. Okay. Using those operators, for example, equal to, if certain things are equal in both the table 1 and table 2, tuples of table 1, tuples of table 2, if those are matching, then I'm going to join them. Join and I'm going to display that particular tuple. That is what join means. So in SQL joins also, just like we have studied, we have inner join. Now inner join is nothing but returns the row when there is a match in both the tables. When both the table contents match, then we will call it as an inner join. Left join is nothing but, for example, if I'm taking the same example, that is T1, suppose the contents of certain tuples, attributes A1 and A2, A1 as well as A2 of this is matching with the B1 and B2, then what I will do, I will display this as well as rest of the attribute. For example, A3, A4, these are the other attributes which are present in this. I'm going to display that as well. So I'm going to display A1, A2 from that first table and B1, B2 because those are matching. Apart from that, all the other attributes of the left table, which is my A3 as well as A4. When I display, it is called as a left join. Okay, so returns all the rows from the left table, even if there is no matches in the right table. Okay, similarly, opposite to that is right join. Suppose I have a table 1 which has attribute A1, A2, and A3, and I have table 2 which has attributes B1, B2, and B3, and suppose only these two are matching, then in right join, what happens is I'm going to take only the matching tuples from the table 1 and all the other rows from the table 2. This is called as a right join. If I'm doing the opposite of that, that is called as a left join. Next we have is a full join. Full join returns the rows when there is a match in one of the tables. Whenever there is a table tuples matching in one of the table, then we are going to return the rows whichever is matching. That is called as your full join. Self join is used to join the table to itself. So there are certain situations where I will have a single table, okay, A1, A2, A3, I will have these attributes. When I am joining this with the same table, that is called as a self join. Okay, so this method is used in certain situations where we will have to retrieve the data. For example, an employee table, in an employee table, then an employee is an employee as well as he is a manager, isn't it? So that time what we will do is we will do the self join because I want to retrieve the details of the manager as and that manager is employee. So in that case, I'll be using only one table, that is your employee table. I will do the self join with that and then I will retrieve and find out who is the manager in that. Next we have is a Cartesian join. Cartesian join is nothing but multiplying each record. For example, here I will combine A1 with B1, A1 with B2, A1 with B3. Similarly, A2 with B1, A2 with B2, A2 with B3, A3 with B1, A3 with B2, and A3 with B3. This is called as Cartesian join. So when I'm joining each tuple of one table with all the other tuples of the table. So for example, if I have 3 rows in one table and 4 rows in another table, then Cartesian join will produce 4 into 3. That is 12 rows in a resulting table. So these are the different SQL join types, right? So now, for example, how does it work when it comes to the SQL? Okay, So if at all I am using a select operation, for example, I will say that I want to select I have these two tables which are connected to each other with the help of a person ID, because as you can see here, suppose this person ID is a primary key of person table, and the person ID is also present in the orders table, hence it will become a foreign key. So through the foreign key, it is connected. They have a relation here. Now, suppose I want to retrieve the person, for example, last name of the person, first name of the person, age of the person, as well as the order ID. These are the things I want to display in my result wherever there is a match between the person ID, which means I want to match these two tables. So the command for this will be select. I will use a aliasing concept here. So aliasing concept is nothing but instead of writing the entire table name, I will use the alias of that. For example, P dot last name, comma, P dot first name, comma, P dot age, comma, I need order ID also. So I will give O as aliasing. So O dot order ID. Okay, from. So these are the rows I want. So from where am I fetching these? From two tables, isn't it? So I will write person. I've aliased it as P. So person space P, comma, and also I am retrieving it from orders. So orders space O. So this is the aliasing. So wherever you see O, it means it is an orders table, and wherever you see it means that it is a person table. So I will write select. I'll write the mention the entire columns, attributes which I want to retrieve, and then I will write from the tables, right? Where, next I want to say where, I will say P dot person ID is equals to P dot, sorry, O dot person ID. Now, what exactly is happening here? First thing is, as you can see this line, this is where your join operation is happening. There is going to be a Cartesian product happening between these two tables, which means this particular column, the row will be multiplied with all the other rows of the second table. Similarly, the second row of the first table will be multiplied with first, second, third, and fourth. Similarly, the third one. The third row is also going to be multiplied with the first, second, third, and fourth. So when I multiply this, I'm going to have all these attributes. That is your person ID, last name, first name, age, order ID, order number, person ID. Imagine it to be written as so order ID, order number, and person ID will be here. Okay, so we will have these many. This will be the Cartesian product result. So in that, what I'm going to fetch, I'm going to fetch only the last name, and then I will fetch the first name. I will fetch the age, then I'll fetch the order ID. Now, am I going to fetch all the rows? No, I'm going to fetch the rows wherever the P dot person ID is matching with the O dot person ID, which means I'm going to only fetch wherever this person ID is matching this. So which means this row, whenever we have multiplied this with this one, I'm going to fetch that row. Next, I'm going to fetch 2. I have 2, so I'm going to fetch this and this Cartesian product row, and then I'm going to fetch these. Okay. So these are the rows which I'm going to fetch. So totally I'm going to fetch only 4 rows will be displayed. So this is how your join operation actually works in your SQL. So every time you are fetching the data from two tables and you write this from person P, person order, you write comma and you write the two table names. That is where your join operation happens between the two tables. Okay. So this is your join operation. Next we have null. So what is this null? Like we have discussed before, null is not equal to 0. It is not similar to 0. Null can be a missing value. Okay, so there is a various reasons for a missing value. Missing value can be because maybe that particular value is not applicable. How does a value not applicable? For example, I am filling a form, and in the form there is a mobile number column. Okay, and that particular student may not be having a mobile. It is not necessary or mandatory that everybody should have a mobile number. Hence, the student has left that row blank. So hence this is called as a null. Okay, it is a missing value. There may be reason that the data is not applicable. There may be reason that data was available and it was missing. There may be various reasons why we have kept null. But null never means that it is zero. Null is entirely different. Okay. A null value in a table is a value of the field that appears to be blank. A field with null value is a field with no value. It doesn't mean it is zero value. Zero is also considered as a value. So we will say no value, not zero. We will say no value. A null value is different than zero value or a field that contains spaces. Okay, so always remember that. So why are we talking about null here? Now, every time we have a database, there is a possibility that we would want to have our table not to have nulls. That is, every time I am going to create a table, I would want the user to enter some value. I do not want him to leave it blank. In such situations, I can always give something called as a not null constraint. Just like we have learned different kinds of constraint, there is something called as a not null constraint. Here, as you can see, create table persons ID int. This is the data type. And I'm putting a constraint saying not null, which means every time you do the data entry into this particular table, if at all you're trying to leave a space blank for ID, then it will throw an error saying you cannot leave space for the blank space for ID because it has not null constraint. Similarly, last name, variable character 255. This is also not null. Here also you cannot leave the space blank. First name also not null, but here as you can see, age is int, which means there is no not null constraint here, which means you can leave space for age, right? So this is how it works. So we can use the is null or is not null operator in order to check for all a null value. So this is another way. For suppose there is a table which has already been created. If at all you want to check whether the value is null or value is not null, then it is a possibility you can do it with these two operators. Okay. So how do I do that? For example, here, select ID, name, age, address, salary. Okay, so all the attributes whichever I want to select from employee where salary is not null. So whenever I put this, if at all in my table, I have salary column. Suppose I have entered some values here, 10,000, I have left blank, then I put 20,000, then I put 30,000. So in this case, this is nothing but null, isn't it? So when I say null, whenever I'm saying where salary is not null, which means I'm going to fetch the ones which does not have blank space for salary, which means these three rows will be selected. Suppose I gave where salary is null, in that case, I'm going to fetch this row which has null as a value for the salary. Okay. So we will do the practical of this, that time we will be clear. So as you can see here, this is nothing but where salary is null. This is the other way of doing it. The last operator for today, what we are going to learn is renaming. So renaming is used in order to rename. This particular one is used in order to rename the column as well as the table. So alter table, I will use the alter table command. Alter table, I will write the table name. Then I will use the keyword rename. And then you will use the column keyword. Then you have to write old name to new name. This is the syntax. And then if you want to alter the table name itself, then you will use the command alter table name, rename to new table name. Okay, directly when you write this, your table will be renamed. Now let us go ahead to the practicals of these commands, what we have learned. Now, for join operation, what we have done, we had already created two tables in the previous sessions. So those we will just use them. Okay, so let me select star person. This was one of the table which we had created. Another one is orders. So let's start from. Okay, now these are the two tables which we had created in the previous sessions when we were doing the practicals. Now let us use this for the join operation as well. Now what I'm going to do is, as you know that your person ID is the primary key in the person table, as well as person ID is the foreign key which is pointing at the person table in the orders table, and order ID is the primary key of the orders table. Okay. All these I have discussed and I have shown practically in the previous session. So if you have not gone through, if you're not understanding that, kindly go through that first and then come back to this video. Otherwise, it is going to be difficult for you to follow. Right. Now, what we have common here is person ID. So let us join these two tables and let us try to retrieve the data where the person ID is matching. So according to that, I should be getting only 100 and 104 person IDs, which is 100 belongs to Reena and 104 belongs to Rai. Okay. So let us do that. Let me say select. I'm not going to say select star because it is easy to say select star, but let us see the aliasing and all how it works. So I will say select p dot person. I don't want person ID because we are already matching that. If you want, you can even give person ID, not an issue. I will say p dot name, comma, p dot address, comma, p dot, let me take salary, comma, o dot order ID, comma, o dot I will take order number. Remember to give only those names, as in if at all you have put underscore, you have to use that underscore. Whatever the attribute you have names given, you have to use it exactly. Okay. So here I have given name. So P represents person table and O represents orders table. That is the reason wherever I have given P dot name, I have tried to use the same attribute name. Similarly, here I have used the attribute names which belongs to them. Okay, so these are the attributes I want. After the attribute, I will say the table name. So from the first table I want here is person. So person. After that, I will give a space and write my aliasing. I have used P as my aliasing, comma, orders, O as aliasing, right? Now here is where our join happens. Person P, orders O. This is where the cross product happens and then we will get the required value. Now what is that required value? I want where P dot person ID P dot person ID should be equal to the person ID which is present in my orders table. So O dot person underscore ID. Okay. So this is my result. As you can see here, wherever the person ID is matching. So which means the cross product has happened with the first row with both the rows, second row with both the rows, third row with both the rows, something like that. And we have got a huge Cartesian product table. In that product, this particular condition has been checked and the result has been showed here. So I have my name, address, salary, order ID, and order number. Remember, these three belongs to the person table and these two belongs to the orders. Still, we are getting it together, which means we have joined it together. And it is satisfying the condition that my person ID should be matching the person ID which is present in my orders table. Okay, I hope this is clear. This is our join operation. Now let us go ahead and do a not null constraint. In order to do a not null constraint, I will have to create a table. Let me quickly create a small table and I'll insert few values and I'll show you how it works. So let us create a table. Create table student. Let me take roll number as integer and I want to have a not null constraint here. Then I will have, let me take name, variable character. I will also give this also a not null constraint. Next, let me take age. And here I'm not going to add any constraint. Let us quickly create a small table. Okay, so this is a small table which with the three attributes. Let's describe and show you. Okay, so as you can see, roll number should not be null and name should not be null. Okay, name I have given it a little bit wrong. That's fine. Okay, let us go ahead and let us try to alter. We will use the alter command here. So I want to change this NMAE I have used. Let me change it to name properly. So alter table student. rename column. I should write old name, that is NMAE to name. Okay, table alter. Let me just describe this once again. Now the table name has been changed. Okay, this is how we change the alter the table name. So we have done that as well. Now that we have created, let me just try to insert the values. Insert into student values. Now I have roll number, so let me give 100, comma, name, let me give Harish, and age, let me give 90. One row has been created. Now let us reuse this. Now what I will do is now I'll try to not to give value for roll number. Let us see what happens. Remember, I have not created it as a primary key. I have not put any primary key, no other constraint, only not null constraint, which simply means that I have to give certain value. I cannot leave the value blank. So insert into student. Now the rows for which I want to give values is name, comma, age. Age. Okay. Now let us remove this. I will remove the register number. Let me change the name to Girish. Okay. Now, as you can see, what I did is I was trying to insert the values. Now, why did I put this name and age and I did not do it here? It is simply because we have already learned how the various ways of inserting value into a table. This is one of the shortcut ways to insert the value where I will directly write the values. So whenever I use this method, I will have to write the values into all the attributes. If not, then I will have to specifically mention the attributes names and then the values, if not entering for all the attributes. So here what is happening is I wanted to leave roll number. That is the reason I have also put the names of the attributes, that is name and age only I'm entering value, and the values are Girish and 19. But it is still not allowing me to enter the value. It is saying cannot insert null into system dot student dot roll number. So system is my database. Under that, I have a student table, and under that, I have a roll number as an attribute. So this roll number cannot have a null value, is what this error is telling me. So let us now what we do is, since roll number as well as name is not null, let us try removing age and see whether we will get the same error. Roll number, age. Okay, let me, in this particular case, I will give all the values 102. Okay. Now the row is being created. Now let us remove age. Remember here, even if you're giving duplicate values, it is not going to give you any error because it is not a primary key. Okay, it is the only concern of this not null is it should not give a blank value. Starting, I need roll number. I don't need age. Okay, wonderful, created. So I hope you can understand the difference here. What exactly is happening is wherever I have given a not null constraint, if at all I'm trying to leave that value blank, then it will not allow me to enter the row. Okay, in order to enter the row, I should give the value, otherwise it will give me error. So let us just see our table. Select star from student. Okay, so I have two rows with age and I have one row without the age. Now let us use is null what we have used. So select star from student where age is not null. What is the meaning of this? When I say age is not null, I want to select star. That is all the rows from the student table where age is not null. Age should not be null, which means I should get these first two rows. Yes, I'm getting these two rows. Next, let us try is null. Okay, which means I should get a row which is null. Of course, I'm getting the very first. That is the Satish student's detail because I have not given the age. So this is your null constraint with is not and is null constraint as well. Right? So that's all in today's session, students. We have already seen how to change the column name as well. Let us see you all in the next session. So thank you for watching. Keep learning.